Welcome back, students. In this video, we're going to go over Module 6, Topic 3, Medians and Altitudes of Triangles. Excuse me. Apologize for the audio difficulties in the last two videos. Thank you to Kamari for letting me know there was no sound. I don't really check the videos. I just throw them out here for you guys and get ready for the next day. So thanks, Kamari. I got it fixed, and here we go. This is page 8, excuse me, of the Module 6 packet. Again, Topic 3, standards are GR 1.3 and GR 3.3. You can read the standards right there on the page. The objective, you guys are going to solve problems using medians and altitudes of triangles. This is going to be an abbreviated video for a couple of reasons. One, I didn't bring the one of the classroom calculators home. I want to go over, and I'm going to do a separate video, but I want to go over using the calculator for the Pythagorean theorem. It'll help you guys as we go progress through the year, and then with the EOC. So here we're just I'm gonna show you the problem. Definitely get a calculator in the classroom. If you're at home, scientific calculator works the same. But the ones in the classroom are going to be the ones you guys have for the test. So that's why I say kind of get used to that one. And that's, like I said, I'll do a separate video for that. So anyway, warm up. You guys know to work this on your own, but I'm just going to work ahead. I mean, I'm not going to go into the whole pause the video. I've already spent more time talking about it than if I'd have just done it. So let's just get to work. So they're asking us to find the measurement of PJ. So that's this line segment. And for angle LXK. So this whole angle. So notice here we know this guy splits this angle in half. So we'll start with the angle. So LXK, angle LXK, is going to be, since this one side is 24.6, this guy's the same. So it's 24.6 times 2. We get 49.2 degrees. So because these guys are congruent, this whole angle is 49.2 degrees. Okay. All right. Now, I'll zoom in just a hair here. For our side, PJ, notice we got a right triangle. Across from that right triangle is the hypotenuse. This is your C square, or your C in this thing. This is B, and this is your short side, A. Now, when we have C, well, in reality here, A and B, it doesn't matter which is which, as long as it's the two shorter sides squared added together to this guy squared. So since we have C, it's going to be C squared minus B squared is going to give us A squared. That's PG. So C squared is 7.3 minus 5.6 squared gives us A squared. So, excuse me. I'm gonna do all the math. I'm just gonna tell you that PJ, or A, once we do all the math here, it ends up being 4.7. I believe it's 21.93 when you square this, then square this and subtract them. But the final answer is 4.7. Like I said, look forward to the calculator video. Till then. All right, backing up a little bit here. Give me one moment. Okay, so we're going to scoot up. Let you guys be, for those of you that watch the video just for the notes, there's your notes. I'm going to color these in real quick. Just a moment. Okay, so In a triangle, a median is a line segment with endpoints that are in the vertex of the triangle, which is the angle, and the midpoint of the opposite side. So in this angle, it dead ends into the midpoint here. All right, so every triangle has three medians, has three sides, has three angles, has three medians. In a minute, it's going to have three altitudes. This is a common theme. So anyway, those three medians meet at their point of concurrency. It's called the centroid, and it's always inside the triangle. We're going to see that the altitudes can be outside, but for here, these are all going to be inside. So that point of concurrency is called the centroid. Now let's move down just a touch here. So theorem 6.7, that is the centroid theorem. It says the medians of a triangle intersect at a point called the centroid that is 2/3 the distance from each vertex to the midpoint of the opposite side. So let's see, all polygons have a balancing point or center of gravity, just like we have a center of gravity. This is the point at which the weight of the region is evenly dispersed and all sides of the region are balanced. The centroid is the center of gravity for the triangular region. You guys that are familiar with center of gravity. So, real quick though, before we flip the page, 2/3 from the distance of the vertex. So if this is the centroid, here's the vertex. So this is 2/3. Well, where's the rest of it? The other way is 1/3. Okay. So whatever this total is from the centroid to the side is 1/3. You will divide that number by 3 if you have the total. This side is 2/3. So if when the problem gives us this number, we're going to multiply it by 2 to get that. If the problem gives us the long side, the side that goes into the angle, we're going to divide it by 2 to get this side. You'll see what I'm saying on the next page. Okay. All right. Page 9. In triangle ABC, P is the centroid. BL is 6. Find BP and PL. So BL is the whole line. It's 6. Or we said divide it by 3. So 6 divided by 3, if this is 1/3 and this is 2/3, 6 divided by 3 is 2. So PL was 2. This side, 6 goes into 2/3. Wait. 4. So then say 4 plus 2 equals 6. So BP equals 6. Now, if you wanted to do math, you could say, and this is super easy. I mean, you guys, we did this in class. The ones of you that are watching the video, if you missed it in class, we got this super quick. But just so we see the math, so BL is the whole line. If we wanted to find, let's see, BL would be, how do I do this? How did I write it? Well, actually, so they gave you BL. You would plug in BL was 6. If we were looking for BP, BP is 1/3. No, it's 2/3. Sorry, actually, so let's just do this. Sorry, guys. So PL, see, it's easier for me just to show you than it is to try to math it up here. But 6 divided by 3, that equals 2, okay? BP is going to be 6 divided by 2/3, which is 4. Said it's easier just to do it this way, okay? Number 2 is you do. Please pause the video here. Try to do that. Wait 3 seconds and I'll continue. All right, number 2. In triangle ABC, Q is the centroid. BE, the whole line, is 9. Find BQ and QE. All right, so BQ, all right, QE is 9 divided by 3, which is 3. BQ, if you want to do it this way, you can say BQ is 2 times, no, 2 times, yeah, 2 times BE. Or you could say BE is BQ divided by 2. So, but either way here, so the whole thing was 9. A third of 9 is 3. 2/3 of 9 is 6. 6 plus 3 equals 9. All right, number 3. I'm not going to do all these because we're dealing with the centroid again. So it says that PY is 7. Notice this is going into the side. So this is the 1/3 side. This is going into the angle. So this is the 2/3 side. All right. So this is double this. So 7 times 2 is 14. So LP was 2 times PY, which was 2 times 7, which was 14. Number 4, that's a you do. Please pause here. I'm going to wait 3 seconds before I continue. All right, so number 4 in triangle XYZ, SP is 3.5. So notice this is in the side. This is the 1/3 side. This is in the angle. This is the 2/3. So this is 2 times that. So 2 times 3.5 is 7. PS is 2 times PZ, which is 2 times 3.5, which is 7. All right, let's go down here. Bottom of page 9. Okay. An altitude of the triangle is a segment from the vertex of the triangle to the line containing the opposite side and perpendicular to that side. See, we're a little off kilter here. Excuse me. An altitude can lie in the interior, like here, the exterior, like here, or on the side of the triangle. BD is an altitude from B containing line AC. So there's your example. All right, so let's just look here. Don't worry about this down here just yet. We're on page 10. Every triangle has 3 altitudes. If extended, the altitudes of the triangle are concurrent. The point of concurrency is called the orthocenter. So for right here, the lines containing altitudes AF, CD, and BG intersect at P, which is the orthocenter of triangle ABC. Now, number 5, I'm not working this out yet. And the reason I'm not, if you haven't been to class, this one's a doozy. It's a really, this is a level 5 question. It's got a lot of steps. And, you know, I like to let you guys know that adults aren't perfect, teachers aren't perfect, and I have the answer, and I know how to work the problem, but I haven't worked it out yet. So I'm challenging you guys. I'm going to give you the instructions right here. When I send the link for this video in Teams, I'm going to include the link that I showed in class. You guys that missed, it's a video just on finding the orthocenter. It's very similar to the problem we have, but not exact. Anybody that can work this problem, and don't just use AI and bring me an answer. That's not what I'm looking for. I want the problem worked with the correct answer, and you be able to tell me how you got there. If you give me that, I give you bonus points on the next test. If there's only one or two, I may do more than that. We'll just see how it goes. It's a very challenging problem. So, without further ado, number 5. So, the vertices of triangle ABC are A 4, 0, B negative 2, 4, and C is at 0, 6. Find the coordinates of the orthocenter of the triangle. So, what you have to do, because the orthocenter extends from the vertices perpendicular into the other side. So it's going to go from A into here, from C to here, and from B into this side. Again, I want you guys to check the video or do your own research. Either way, I want to see what you guys can do. I know you guys are smarter than you give yourselves credit, so let's see what you can do with this. So the first step, you're going to find the equation of two of the line segments forming the sides of the triangle. My hint here is just say AB and BC. But you can either two of the three, okay? Let's see. Because two altitudes intersect, the third has to intersect the same point. So you're going to get the equations of two of these. Let's say you get AB. You're going to get the slope, and then you're going to get the y-intercept. Get the equation for these two line segments. Then we're going to find the slopes of the altitudes. The hint, altitudes are going to have a slope perpendicular. So whatever the slope is for AB, the altitude for that's going to be the negative reciprocal. BC, same thing. So you're going to take the altitude, you're going to take the perpendicular slope to your two lines here, use the opposite angle. So for AB, it's opposite angle C. That's the point you'll plug in to get your y-intercept, so you have your equation for your altitudes. Then once you have your two equations for your two altitudes, now I got into step 3. Step 3, you're using the opposite vertice, like I said, to find the equations. So you're using point C for AB, point A for BC. Which gets us down to step 4. Then you're going to solve the corresponding x and y values that are going to give you the coordinates for the orthocenter. So when you get these two equations, it'll be y equals blah, blah x plus whatever number. Same thing over here. Forget the y. It'll be whatever the mx plus b is to the mx plus b. That will solve you for x. So that'll give you the x coordinate for the orthocenter. You plug x back into either one of those altitude equations, and that will help you solve for y, which will be the y coordinate for the orthocenter. So as you can tell, it's a lot of steps, but I want to see what you guys can do. Let me know if you have any questions. Please see again the other video I'm sending. It's a educational video. I forget who put it out, but it'll be in the team's message with the link to this video. Until next time, have a good night, you guys.